Let's take a look at this problem. Jane took 15 minutes to drive her boat upstream to water ski at her favorite spot. Coming back later in the day at the same boat speed took her 10 minutes. If the current in that part of the river is 6 kilometers per hour, what is her boat speed in still water? So, drove her boat upstream to water ski at her favorite spot. Coming back. Okay, so we had our starting place here, and this is the place where the water ski occurs. So we're going and coming back. Jane took 15 minutes to drive her boat upstream. So time here is 15 minutes. Upstream. That means that the water's working against you. Wait a minute, upstream. Come back later in the day, took her 10 minutes. We'll go ahead and write that down first. So coming back took her 10 minutes. Okay, so took her 10 minutes means that her rate was increased by 6 because the current of the river is 6 miles per hour. So since I had to do the minutes to see which one was faster. So this one has to be R minus 6. Since it took longer to get up there, that means water's pushing against the boat and slowing it down. And that's why this has to be a minus. This one, since the time was less, means that the water has to be behind the boat and making it go faster than its actual rate. Okay, I guess that's all the information. Well, we know that this distance is the same as this distance, so our distance going is going to equal the distance coming back. Okay, the distance going. Distance is equal to R times T, so here our R is R minus 6 times 15 minutes. Now distance coming back, R times T, so we'll have R plus 6 times 10 minutes. Now, notice 6 is in kilometers per hour. These are minutes, so we need to convert these to hours so they'll be the same unit of measure, since 6 is in hours. Okay, well, to convert that, we'll divide it by 60, and that'll convert it to hours. And same over here, I'll divide it by 60. I'm going to drop the hours because I know what my final measure is going to be. Now 15 over 6 is 1/4. So I got 1/4 times R minus 6 is equal to 10 over 60 is 1/6, which is that times R plus 6. Now, going through my steps for solving a linear equation, first step is get rid of parentheses. We do that via the distributive property. So I'll take the 1/4 and multiply it through, and I'll take the 1/6 and multiply it through. 1/4 times R is 1/4 R. 1/4 times negative 6 is negative 6/4. 1/6 times R is 1/6 R. And 1/6 times 6 gives us 1. 1/6 times 6 is 6 over 6, or 1. Now, second step, we want to get rid of fractions. I could simplify the 6/4, but it wouldn't help me any here. So I'm going to multiply by the LCM of all my denominators. I got 4, 4, and 6, so my LCM would be 12. So I'll take 12 times 1/4 R minus 12 times 6/4 equals 12 times 1/6 R plus 12 times 1. And that gives us 3r minus 4 and 12, multiplied by 4, that gives us minus 18. And this gives us 2r, and 12 plus 1 is 12. Third step, we want to get everything with an r, all the terms, on one side, the numbers, the constant terms, on the other side. So I'm going to take that 2r, move to the left side. You take anything across or equals, your sign changes, so 2r becomes a negative 2r. Take the negative 18 to the right side, becomes a positive 18. 3r minus 2r is r, and 12 plus 18 is 30. So that would be our boat speed in still water. So if I put 30 in there, that's how you solve that particular problem.